In this video, we'll look at the remainder of Unit 8. So Section 8.4 is converting decimals to fractions. So we looked at converting fractions to decimals in a few different ways, and now we'll look at converting decimals to fractions. Okay. So from the last unit, they should be fine with rewriting a decimal in its fraction form. Okay. So they should very easily, I hope, be able to write this as 8/10, 65/100, 44/100, and 2/1000, etc. One thing you want to note when you show them how to simplify this is, since the denominators are powers of 10, a nice result is that all we have to do is look to see if the numerator is divisible by 2 or 5 to simplify. Okay, so 10 only has prime factors of 2 and 5. So if the numerator is even, divide by 2's till you can't anymore. Okay, if the numerator ends in a 5 or a 0, divide by 5 or 2 or 10. Okay, so 8 over 10. You could either have them write this factored or have them divide on the top and bottom, whichever you prefer. These cancel to 1. And I think you get the general gist of this. Here you can tell them, well, it's divisible by 5. When they're done, they get 13 over 20. And they'll know this is completely simplified because 13, well, it's prime, but for them, it doesn't end in it's not even, and it doesn't end in a 5. So it's completely simplified. So that saves them some time. Okay. Then we use the same idea, but give them some negative numbers and some mixed numbers. Okay, so here you have them rewrite it as a fraction or a mixed number. In this column, they just simplify the fractional part. We leave out the whole number part of the mixed number till the final answer. That's pretty straightforward. And then comparing decimals and fractions. So one thing here that may be a little bit different than how you normally teach this is I think typically when students go to compare these, they just rewrite the fraction as a decimal. And of course, that's an option. That's probably how I do it most of the time. But also, before I'd rewrite a fraction as a decimal, I'd probably use benchmarks. So we talked about benchmarks such as 1/2. So noticing here, 5/8 is bigger than 1/2, since 5 is bigger than 4. 5/10 equals 1/2, so I know 5/8 is bigger. Okay. 3/8 is less than 1/2. 64/100 is bigger than a half, so 3/8 is less than 64/100. Okay, so getting some of these ideas in so they can compare the numbers without always dividing on the calculator. Okay, and then some of these can be tricky. We know 4/9 is 0.4 repeated. Okay, and sometimes they have trouble realizing the 0.4 repeated is greater than the 0.44, or you may have something that rounds and is close, okay, but the rounded up version actually is larger. So, for example, if we have 2/3 and 0.67, we know that 0.67 is greater than 2/3. 2/3 is this 6 repeating forever. Sometimes they think the repeating forever somehow makes it infinite or trumps the fact that this has a 7 in the hundredths place. Similarly, if we have 1/3 and 0.33, okay, 1/3 is bigger than 0.33 because the decimal repeats forever. So it's good to have them look at some of those just to clarify that idea with repeating decimals.